Welcome to Good for Nothing Audio Lab. My name is Young. Today I'd like to show how to match high-power triode 6C33C-B briefly. I purchased 8 Russian new old stock twin power triodes to get one matched pair for my friend Steve. Even though these were produced 60 years ago, physical condition is excellent, but nobody knows how well the electrical spec is good or not until to be tested. As you see, one matched pair was already working great for model A331, but Steve wanted to make another pair for just-in-case situation. As mentioned earlier, the 8 vacuum tubes all differ in their specifications, making it a matter of luck to find those that truly suit this amplifier. So now, I will begin the process of testing them, fitting each one into the socket in turn. To measure the plate current, connect a digital multimeter to the cathode terminal of the 7-pin socket. The measurement mode must be set to DC voltage. Since a 10 ohm voltage sensing resistor is connected to the cathode terminal, the displayed voltage can be easily converted into current. For example, 0.4 volt is 40 mA. One of the most notable characteristics of this 6C33C-B amplifier is the enormous inrush current that flows when the power is switched on. Therefore, it is strongly recommended to use a sufficiently rated slow-blow fuse. Now, let us observe the speed at which the plate current flows. Based on my nearly 15 years of experience building Soviet-made vacuum tube amplifiers, this rate is excessively fast. It is likely that the current will exceed the ratings of the first matched pair by a considerable margin. In some cases, this vacuum tube may become unusable in any amplifier, thereby increasing the overall purchase cost. Now, let us examine the second tube, namely V5. Compared to the previously tested V4, it is evident that the plate current rises much too quickly. If such a level of current continues to flow, it would place excessive stress on the power transformer, becoming a factor that could easily cause amplifier failure. Therefore, I already have no choice but to discard 2 of the tubes. I quickly removed the 2 out-of-spec tubes and installed the third one into the socket. At last, the rate of plate current increase feels much more stable. With some luck, I may be able to achieve my goal. Around 70 mA of plate current, encouraging signs can be observed. The lower portion of the sine wave shows slight distortion, but this will gradually improve over time, and once the desired current value is reached, it will appear in a form that is nearly perfect. The same applies to distortion. At present, it measures as high as 4%, but at the proper operating current, it will drop to around 2% even at maximum output. Finally, I was able to measure the plate current I had been aiming for. It only stabilizes about 10 minutes after powering on the amplifier, and after that, it must never rise again. Measuring the electrical characteristics of the 6C33C-B amplifier with precision truly requires a lot of patience. I hope this video will be helpful for your DIY projects. I wish you good luck. Thanks for watching.